Hello everyone, today's video is going to be on chapter 11.3, determination of right angle triangles, where we are going to be looking at workbook exercise 11C, page 131 to 132, and only covering question 1, 2, and 3. So the first question that we are going to be looking at is to determine if each of the following triangle is a right angle triangle. In part A, we are given a diagram, and in the diagram we have the dimensions 4, 7, and 10. So to determine whether this triangle is a right angle triangle or not, we will be using our Pythagoras theorem. And in order to do that, we need to determine which one is the longer side, because the longer side out of these three will be the hypotenuse, and that would be 10. So after we determine the longer side, or rather the hypotenuse already, we consider 10 square, which is going to be equals to 100. Then we take the sum of the other two remaining sides, or rather the sum of squares of the two remaining sides. That means 4 square plus 7 square, and that will be equals to 65. So now that we have computed for each of these statements already, we will see that one of it is equals to 100 and the other one is 65. Hence, they are actually not equal. So since they are not equal, then by Pythagoras theorem, the triangle is not a right angle triangle. And now we take a look at part B, where we are also given a diagram, and the three sides, the length of the three sides that are given is 9, 12, and 15. So 15 being the largest number, that means that it will be the hypotenuse. So we will compute 15 square to be equals to 225, and then we compute for the value of 9 square plus 12 square, and using our calculator, we also get 225. Alright, so because we see that 15 square and 9 square plus 12 square, both of it are equals to 225, we can say that they are equal over here. Then we say by Pythagoras theorem, the triangle is going to be a right angle triangle. Then moving on to part C, we want to find whether this triangle with the sides 21 cm, 24 cm, and 28 cm, is it actually going to be a right angle triangle or not? So same as before, there is no diagram given in this question, but the diagram is actually not necessary. So same as before, we look for the longer side, which is 28 cm. We determine 28 square, which is 784. And then we look at the remaining two sides, and we take the square and sum them up, and that will be 1017. So we see that both of it are actually not equal, so we will say that they are actually not equal here. So by Pythagoras theorem, the triangle is not a right angle triangle. Moving on to part D, we are given a triangle with lengths 0.25 meters, 0.6 meters, and 0.65 meters. So we will also identify which is the longest side, and that will be 0.65 meters. So that will be the hypotenuse. So we find out what is 0.65 square. That will give us 0.4225. You may of course leave it as a fraction, that will also be fine. And then after that, we take the remaining two sides, we square them, then we sum them up, and we also get 0.4225. So we see that both of the values are equal, so therefore we can say that they are equal, and by Pythagoras theorem, the triangle is going to be a right angle triangle. Next, we take a look at question 2, where we are given that a metal ramp is constructed to stop vehicles at a security checkpoint. It is crucial for the cross-section of the ramp to be a right-angled triangle in order to facilitate the movement of the ramp. Using the dimensions given in the figure, show that the cross-section is a right-angled triangle. So we just have to rely on the diagram that is given to us, and we check whether it is a right-angled triangle or not. So we identify that 39 is the longer side, so we find 39 square, which is 1521. Then we take the sum of squares, of the remaining two sides, which is 15 square plus 36 square, which also gives us 1521. So therefore, we can say that they are equal, and by Pythagoras theorem, we will conclude that the cross-section is indeed a right-angled triangle. Moving on to question 3, we are given that AB, BC, and AC are sides of a triangle. There is no diagram given. You may want to actually draw a diagram to facilitate your visualization, but actually that isn't fully important, because we know that we just need to be able to identify which is the longer side, to know which is the hypotenuse. So we can have ABC. At this point, we don't know whether it's a right angle triangle yet, so to be honest, it isn't very important to in terms of the way the triangle is being drawn. So we see that this is 15 cm, BC is 12 cm. Okay, so you realize that in my sketch it is actually not proportional, but never mind. Okay, so we it is, the important part is to identify that AB is actually the longer side because it is 15 cm long. So we see AB square is 15 square, which is 225. Then we take the remaining two sides, BC and AC, square them, then after we add them up, and we also see that it is equals to 225. So now we have AB square to be equals to BC square plus AC square. Then by Pythagoras theorem, okay, we can conclude that triangle ABC is going to be a right angle triangle. Okay, just to add on to this question, okay, what if the question asks you where is the right angle? All right, so let me erase this diagram because it doesn't serve much purpose in the question actually. So my extension question is, all right, if they ask, okay, determine if triangle ABC is a right angle triangle and identify where is the right angle. Okay, so to identify where is this right angle, right? Okay, because we know that AB is the longer side already, so now maybe let me draw a slightly more accurate diagram. Okay, so in this case, when I'm trying to identify the right angle, okay, it is slightly more useful for us to have a diagram. So we know that there must be a right angle here because it must be opposite the hypotenuse, which is 15 cm. Then after that, the 15 cm is actually AB. So I can label this A, this is B. It doesn't matter which corner do I label as A and B. Okay, I can definitely also have this as B and then this as A. That is fine as well. Okay, so if I go back to what I had earlier, right, AB, then the remaining side must be C already. Okay, then BC is 12 cm here, and then AC is 9 cm. So actually, I now have a more accurate representation of this triangle that we are talking about. But let's not forget the question wants us to find, okay, identify where is the right angle. So the right angle having to be opposite the longer side, okay, the hypotenuse. That means that it must be an angle C. Okay, so we can continue to write on that triangle ABC is a right angle triangle where angle ACB is equals to 90 degrees. Okay, so this is how we go about finding or identifying where is the right angle. And now we will take a look at the very last part, question 3, part 2. Okay, the question says that if the length of each side of the triangle that we discussed earlier is increased by 1 cm each, okay, would triangle ABC is to be a right angle triangle? So what do you think? Do you think that if I have a triangle, just now we were discussing the triangle to look something like that. Okay, this is 15 cm and then BC is 12 cm and AC is 9 cm. So if I were to just extend it by a bit, okay, extra 1 cm only, okay, having extra 1 cm, do you think it will still remain as a right angle triangle? Oops, sorry. Okay, so let's check it out, all right, and we have to prove it by our Pythagoras theorem. Okay, so with each side being increased by 1 cm, that means my AB will become 16 cm now, BC is 13 cm, and AC will become 10 cm. So same as how we usually do our proving, okay, we find the longer side, which still remains to be the side AB, that will be 16. Okay, so AB square is equals to 16 square, which becomes 256. So we do the same for BC and AC, where we take the square and then we sum them up. So we will have 13 square plus 10 square, which gives us 269. Okay, so what happens is that we see that we get 256 over here for AB square, and then after that for BC square plus AC square we get 269. So clearly they are not equal. Okay, so then by Pythagoras theorem, okay, we can conclude that the triangle ABC will actually not be a right angle triangle when each side increases by 1 cm. So it may seem like, if I increase by 1 cm, it doesn't make much of a difference. It should still remain as a right angle triangle. But truth to be told, as we see over here, it is not the case, okay, because our theorem doesn't seem to work, okay. So therefore, by increasing by 1 cm, okay, it will not maintain the property of being a right angle triangle. So with that, we have completed the workbooks exercises 11b and 11c. So therefore, I would like you to complete the homework which I have actually informed you in the last lesson already. Okay, exercise 11b in your textbook. Okay, and exercise 11c from your textbook as well. Okay, so please do it, okay, by 29 June, Monday. I will collect it when we return to school for lessons. Okay, so reminder, this is from textbook. Alright. Okay, that's all for this video for today. Thank you everyone. Bye bye.